Hello everyone, my name is Mengyuan and today I'm going to share with you my research paper which is called Influence of Modularity Technology on Apps Quality. First, I want to introduce this paper a little bit. For a long time, some small companies don't pay much attention to software modularity, considering the cost problem. However, more and more companies realize that modularity is a necessary part of software development recently. The cost of modularity is insignificant compared with the benefits of the modularity. Nowadays, modularity is extremely important for software development and evolution. Good modularity can improve the flexibility and comprehensibility of the software system, while bad modularity can cause expensive refactoring and software defects. In addition, modularization decisions affect traceability of the design, and sometimes code clones define the design principle of modularity, and it makes it difficult to maintain the test programs effectively. So in this paper, I present the influence of modularity technology on different aspects of software quality, such as reusability, extensibility, maintainability, etc. However, a well-modularized design does not always guarantee a well-modularized implementation, and it's difficult to check the conformance between a design modular structure and the source code and modular structure. So I also talks about the disadvantages of using modularity in some specific situations and where it can be used properly. Next, I want to share with some background issue related to modularity with you. The word modularity first appeared in Design Rules, a book exploring the nature of engineering design. Later, the principle of modularization is only a theory of computer science, not an engineering practice. Recently, the modularization of hardware has always been one of the cornerstones of engineering technology, such as standard thread, automobile components, computer hardware components, etc. The principle of software modularization is also born with the complexity of software. From the beginning of the machine code, subroutine division, library framework, and then to the program library on the host computer distributed over thousands of kilometers of the internet. Modularization is one of the important methods to solve the complexity of software. A modularization refers to the division of software into independently named and independently accessible modules. Different modules usually have different functions or responsibilities. Each module can be developed and tested independently and finally assembled into a complete software. The module independence means that each module in the software system only involves a specific sub-function required by the software. The interface between the design of each submodule shall be as simple as possible. This is also an important principle of module design. To measure the quality of module is to use the coupling between modules and the cohesion within modules. For related work, there are so many areas where modularity can be applied, such as applying conception of both modularity and platform into like service design, technical debt, network, etc. Before I go into the details of the paper, I made some assumptions in advance. I believe that the time using on maintaining extension will be decreased significantly after using modularity technology. Besides, not every part of the software is suitable for modularity. Some unique, simple, and unreusable part may not be suited for modularity. Using this technology in those parts may increase the time for maintaining an extension or even increase the possibility of producing errors. So first, for extensibility, there are lots of ways of measuring it. In this paper, I use the metrics below. The possibility of extension, time of extension, money spent for extension, and number of people needed for extension. I interviewed a software architect in ByteDance. The data collected is shown below. According to the results, the overall performance with extension is enhanced significantly after using modularity. The possibility of extension is improved by 70%. The development time of extension is reduced by 40%. The money spent of extension is saved by 3,062 RMB. The number of people needed for extension is saved by 14 days. The test time of extension is saved by 24 days. With modularity technology, it first enhances the possibility of future extension, thus reduce inestimable cost for future development, because with low possibility of extension means that the whole software may need to be pushed down and start over, which will cost much more time, money, and people than expected. Secondly, the time saved in development can be used in testing activities. Besides, the testing time can also be saved because of low coupling of the software. Thirdly, the number of people needed is saved, so that the money spent can be saved because wages are decreased significantly. What's more, saved money can also help company hire more people with modularity skills. All the information above shows that using modularity with extension can reduce the development time and the testing time through the entire software life cycle and save a bunch of money and people which will benefit the company a lot. For maintainability, there are basically four types, which are corrective maintenance, adaptive maintenance, perfection maintenance, and preventive maintenance. Corrective maintenance means correct some potential program errors or design defects exposed under specific service conditions. Adaptive maintenance is to modify the software to adapt to this change when the data environment or processing environment changes during the use of the software. Perfection maintenance is to modify the software so to incorporate these requirements into the software after user and data processing personnel put forward requirements for improving existing functions, adding new functions, and improving overall performance. Preventive maintenance is to improve the maintainability and the reliability of software. Advanced software engineering methods are used to design, compile, and test the software to be maintained or a part of the software in advance, so as to lay a good foundation for further improvement of software in the future. So in this paper, I use the corresponding metrics to describe maintainability, which are possibilities of realizing maintainability, time of finding an error or defect, the time of making a change, the time of adding a new function based on users' requirements, and the time of keeping software's reliability. I also interviewed the software architect in ByteDance. The data collected is shown below. According to according to the results, the overall maintainability is enhanced significantly after using modularity. The possibility of realizing maintainability is improved by 56%. The time of finding an error or defect is reduced by 2 days. The time of making a change is saved by 2 days. The time of adding a new function based on users' requirements is saved by 5 days. The time of keeping software's reliability is reduced by 16 days. The time the time of realizing and keeping maintainability is reduced after using modularity because of flexible architecture, focus separation. Besides, it is convenient for module combination and decomposition, um, debugging and upgrading of a single module. In addition, modularity can also provide a clear structure so that whenever there is an error or defect, developers can always locate it immediately and fix it, so they can save a bunch of time. What's more, whenever there is a change or a new function needed, developers not only can find the right place to modify the code, but also will not affect the other parts of the code. So all the information above shows that using modularity can enhance the maintainability significantly and reduce the workload for developers because they will have a more concise destination to locate at and don't worry about influence of other codes. It not only save plenty of money and save a bunch of people, which will benefit the company a lot. In most cases, modularity promotes the entire life cycle of the software development. However, there are some specific cases where performance loss can become a big problem using modularity. Performance loss mainly reflects on two aspects, which are first, the system is layered, so the call chain will be very long and sending messages between modules will consume performance. Like in some apps, response time plays an important role in terms of users' experience. For instance, nowadays everyone uses instant messaging app like QQ, WeChat, Skype, WhatsApp, Facebook, etc. So all these apps need short response time. No one wants to send or receive messages more than like 2 or 3 seconds. In addition, a video game is another type of app which needs short response time too, because players always desire immediately feedback from the game system after they make a move or do something. All these kinds of apps may not be proper places where modularity can be applied. On the contrary, using modularity in these apps may even decrease the quality of the app and increase the future cost for maintenance. So in this paper, I also conduct a set of experiments to figure out the bad consequence of using modularity on these specific time important apps. Besides, like in some small-scale app, using modularity may also cause bad results. The data collected is shown below. So the result shows that in these special cases, modularity may even become a burden, which means that it will slow down the response time of the system, thus decrease the time of collecting usage data from users. Besides, it also reduces the time of extension and the maintenance, because it also increases the increase the time of extension and the maintenance, because sometimes a small application doesn't need such so complex structure, and the process flow is more suitable for this kind of app. So based on the discussion above, in general, the most important thing for developers to think about is that whether this app can use modularity and where modularity can be applied properly. So first is to I think first to decide is to first is to decide whether to use modularity, because not every app is suited by this technique. In general, I think large-scale software which is not time-critical is suitable for modularity. Then, if modularity can be applied, the next step is to decide use modularity in which part of the software. Do we need to use the modularity in the whole software, or we can just apply it into some parts of the software? The answer is definitely the latter, because for some specific process, modularity will only increase the complexity of the system and the time of execution of the process. Besides, the possibility of producing errors or defects will be enhanced too because of high complexity. Finally, there are some important things to notice when using modularity, such as keep different modules interact with each other, but at the same time you need to keep them doesn't affect each other to ensure stability. Finally, I conduct a social survey on the developers in diverse kinds of companies. Here are some sample questions. Basically, these questions are related to the experience and opinion of modularity from these developers. For conclusion, in this paper, I first emphasize the important role that modularity plays in the entire software industry and introduces diverse kinds of modularity design. Then I illustrate the positive influence of modularity on software's extensibility and maintainability. However, one coin always has two sides, so I also talk about some situations where modularity cannot be applied properly and even may cause bad consequences. And finally, I conduct a social survey to figure out the opinions of the modularity technique from the developers. So that's all. Thanks for watching.